Okay, so here today we're going to be working with problem number 43. And it's just asking us to find the drift speed of the sodium ion if it is in water, which is 5.2 times 10 to the negative 8th meters per second per newtons per coulomb. That's the mobility of that. And then if the electric field is 2,400 newtons per coulomb, if that's maintained. So over here I have my work. It's pretty simple. We know that the speed of the mobile charge carries through a conductor at the constant electric field is the drift speed. And the drift speed of mobile charges is equal to the product of the electric field times the mobility of the charge carriers. And so we know that U is the mobility and E is the constant electric field. And they gave us the mobility, which is going to be 5.2 times 10 to the negative 8th, and that's going to be of water, as it said in the question. And then it's 2,400 newtons per coulomb for the electric field, and that was also given to us. And we know that we can find this pretty common equation. There's more to explain like how to get that equation in another video, but that's pretty much it. We just know that that's what we need to substitute, plug it in, and pretty much plug and chug. Like, it just type in the calculator, and then you'll get the drift speed, which is going to be 1.25 times 10 to the negative 4th meters per second. But since that one was pretty simple, pretty straightforward, I also worked problem 51. The answers are right up top, and the question is going to be this one right over here. It's going to be right here. This is the figure that it's going to be talking about, and it is asking us about how long do we have to wait to make sure that the mobile electron of the C in the nickel block has reached the equilibrium. And as you can tell, I put answer number 1. A neutral block is going to get a charge when it's placed near the charged body, and a pair of opposite charges are going to show up on the block immediately. And so it's going to be option number 1, which is less than a nanosecond. And the second one, it asks us what is the average drift speed of the mobile electron in the nickel block. And so I picked option number 3 because we do know that it is directly proportional to the magnitude of the field inside of the material. And since the electric field inside of a conductor is 0, because that's one of the properties of conductors, inside is going to be 0. We're going to know that in the case of a metal, this would be completely different if it was not a metal. The average drift speed is directly proportional, so that we know if the electric field is 0, we know that the average drift speed is also going to be 0 meters per second. So that's going to be 0. It's going to be answer number 3. And so for the part C of that, it asks us what is the meaning of U. U, as we showed in number 43 here, we plugged in right there. We know that it is going to be the speed at which the mobile charges move through the conductor, and that is the drift speed. And then we know that it is proportional to like we said here, the mobility times the electric field, actually the total electric field at that location of that charge. And so we know that that is going to be, it's going to represent the mobility of an electron inside the metal. And then we used all of that for 43. We just did them vice versa because they showed up like that in the text. And so that is pretty much it with those two.